Hi and welcome to my channel. This video is Beginner to Advanced C++ Pointers course. So in this video you are going to learn about all of the important topics related to pointers. But before I start with the lessons, I want to give you a few tips. So if you need captions or subtitles for this video, I want to say that YouTube sometimes does not allow captions on videos that are very long, but if you really need them, I'm going to link here and in the description a playlist that contains all of the individual lessons from this video, and those lessons contain captions, so if you really need them, make sure to check that out. Tip number 2 is that all of the chapters will also be linked in the description so that you can navigate yourself through the lessons, but my recommendation is to watch the entire video because it is going to be much easier and better for you if you don't skip anything and learn step by step. And if you want to learn about other topics like object-oriented programming, data structures, algorithms, or programming in general, I have a lot more tutorials for you and I will also link them in the description. And one of the most important topics that you should definitely check out is creating graphical user interface applications with C++. One of my most popular videos is this one, where I explain the fastest and the easiest way to build user interface applications. I will link that video in the description, and I will also link a tool that I use in order to create UI applications. It is called C++ Builder, and you can download it and try it out for free using the link in the description. And please follow that tutorial in order to learn more about building your own UI applications. And in that tutorial, you will see how C++ Builder makes it very easy to create user interfaces. So after you watch that tutorial, you will understand how to create your own user interface applications so that any idea that you have, you will be able to translate that idea into an app very fast. So those are the topics that I covered so far on my channel, and if you have any other topics that you would like to see in the future, feel free to write me in the comment section. And before I start, I also want to ask you to please give this video a thumbs up for the YouTube algorithm, and also if you want to support me and my channel and all of the hard work that I put in order to make these videos, and thank you very much if you do that. So now I'm going to start with the lessons. Good luck with learning and feel free to let me know how it goes in the comments. In this video, I want to talk about pointers, so I will go straight to the point. Pointers are a very important concept in C++, and they have many uses in C++. Now, pointers are not limited only to C++. They exist in other programming languages as well, but in most of those programming languages, they are really hidden. They work behind the scenes, so you cannot see them and you cannot use them yourself. But in C++, you can use them and you can create your own pointers, and they can be pretty powerful if you know how to use them, but they can get quite confusing as well if you don't understand them well. So the first thing that I want to explain is what are pointers. So we already have explained the concept of a variable, and you should be familiar with that. So we said that a variable is just a container, so a container that stores certain value. Now a pointer is container as well, but instead of storing value, pointer stores an address, so a memory location. And let me show you how pointers work in Visual Studio. Let's create a variable of type int, and I'm going to call it n and assign it a value of 5. And let's write out this n like this. So nothing new here, we are already familiar with this, and if I run my program, as you can see, we get this value of 5, so that was expected. Now, as I already said, this n is a variable, and that means that it is a container which is storing certain value. Now, because it is a container, that means that it has its address inside memory, so it has its physical location. So how can we get that location? How can we check which address this n has? So in order to do that, you use this ampersand symbol like this. So you put it before your variable name, and that should give you the address of that variable. So if I run my program now, as you can see, now we have an address, and this is the address of our n variable. So this is its physical address where this value of 5 is stored. And because this is pretty hard for humans to remember, this is just a random numbers and characters. Because of that, we use meaningful names, and we access these values that we store in our memory using these meaningful names, which are our variables. So I'm going to close this now. And what I want to show you here is I want to show you how can you create a pointer that is going to hold this address of our n variable. So in order to create a pointer, you give it a type first. So you say int, and then in order to indicate that you are creating a pointer, you use this star symbol, and then you give it a name. So let's call it PTR pointer, and I'm going to assign it the address of our n variable. So I'm going to copy this and paste it here. Okay, now our pointer is holding the address of our n variable, and in order to prove that, I'm going to write out the value of my pointer like this. So as expected, we have this first line here, which is writing out the address of our n variable, and then this second line of code is this line here. And as you can see, we have written out the value of our pointer, and that is the same address as this one here, which means that our pointer really is storing the address of our n variable. Now, you may ask, how can I access, or can I access the value that is stored on that address using pointers? And the answer to that question is yes, you can. And in order to do that, in order to access the value that is stored on this address that your pointer is holding, you have to dereference your pointer. So how do you do that? Well, let me copy this. So as you already have seen, this line of code here is going to write out the address, and in order to write out the value on that address, you dereference the pointer. And in order to do that, you add this star symbol before your pointer's name. So if I run my program now, as you can see, in this last line of code, we have the value of 5, which is actually the value that is stored on this address here. So let me show you one more thing. What I want to do is I want to change the value that is stored on this PTR address. So on this address that our PTR pointer is storing. So how am I going to do that? I'm going to say, again, star symbol and then PTR. And this here means please access this memory location. So whatever I'm going to assign here is going to be stored on that memory location. And what I want to assign is, for example, value of 10, like this. So now if I copy this line of code and then paste it here, and if I run my program again, we have this value of 10 stored on this address here. And one interesting thing as well is that if we try to write out the value that our n holds now, like this, if I run my program, as you can see, our n holds the value of 10 as well, even though we have never said that n has the value of 10, but we have stored the address of our n in our pointer, and then we have dereferenced our pointer, meaning we have changed the value on that address here in this 11th line of code here. So that's why our n holds value of 10 now. One very important thing to keep in mind is that your pointer has to be of the same type like the variable that it is pointing to. So let's close this. So as I said, this integer pointer is pointing to an integer variable. So our n is of int type. And the same way would be if we created a float pointer, it would have to point to a float variable, and then char pointer can point only to a char variable, double, bool, and so on. So pointer and the variable that that pointer is pointing to have to be of the same type. Okay, so that means that if I try to change the type of this n variable to float, for example, like this, so if I say float, immediately we get an error here, and the error says a value of type float pointer cannot be used to initialize an entity of type int pointer, meaning you cannot assign address of a float type to pointer of int type. Okay, so that is the error that we have here, and I'm going to return this to int. Okay, and as you can see, that error has disappeared because now our pointer is pointing to the same type, so to the variable of the same type that that pointer has. So int pointer pointing to an int variable. One thing that beginners very often try to do is the following. So they say, okay, let's create a pointer. So int, let's give it a name ptr2, so pointer, like this. So I have created a pointer, right? So let's dereference this pointer and assign it a value. So I'm going to say, please dereference ptr2 and assign it a value of 7, for example. Now, this code here has a problem. And if I run it, if I say build solution, actually, as you can see, it says uninitialized local variable ptr2 used. This means that this ptr2, so this pointer 2, does not have an address. So where should it store this value of 7 if it does not have an address? And the easiest way right now to solve this problem is going to be to create a variable and to give the address of that variable to our ptr2 pointer. So I'm going to say int v. This variable has to be of the same type as our pointer, as we already said. And then I'm going to say here our ptr2 is going to hold the address of our v variable like this. And now we shouldn't have this problem anymore. So if I build my code again, as you can see, one succeeded, so the problem has disappeared. And let me write out the value of this v variable. So I'm going to say v is equal to, and then let's write out the value of this v. And if I run my program, as you can see, it says that v has the value of 7 because we have assigned it here by dereferencing our pointer that is holding the address of our v. So you may say now, okay, Saldina, I understand this, but this seems a little bit too much. Why would I create a pointer just to assign a value to a variable? And the answer to that question is you don't. This is not the type of problem for which pointers were created in C++. So there are different problems that pointers solve in C++, and this here is just a demonstration of what are pointers and how can you create your own pointers. Now, examples of some of these other problems that pointers solve is you can use pointers in order to pass values by a reference to a function, and then you can use them to return multiple values from a function, which is an interesting one. You can use pointers in combination with arrays as well. You can use them for dynamic memory allocation, and then if you're familiar with OOP, object-oriented programming, you can use a pointer of a base class in order to access an object of derived class. And then there is this concept of smart pointers, which we are going to cover in the future. So stay tuned, subscribe to my channel, hit that bell icon as well so that you are notified when I publish my next video. And if you liked this one, give it a thumbs up. Thank you for watching, and I'm going to see you in my next video where we will be talking about pointers. Bye! In this video, I want to talk about void pointers. Now, in the previous video of this playlist, I introduced you to pointers in general, so I explained what are pointers and how you can create your own pointers. And I said that a pointer is a special variable that can hold an address. And I said as well that a pointer can hold only the address of a variable that is of the same type as that pointer, which means an integer pointer can hold the address of an integer variable, and then a character pointer holds the address of a character variable, float pointer of a float variable, and so on. But there is an exception to that rule, and that is a void pointer. And a void pointer is a special type of pointer that can hold the address of a variable of any other data type. So a void pointer can hold the address of a float variable or an int variable or a char, bool, struct, whichever one you pass to that void pointer. But a void pointer has a limitation as well, and that limitation is that you cannot directly dereference a void pointer. So in order to demonstrate this, I'm going to create an example with the knowledge that we already have, so using only integer and character and float pointers that we are already familiar with, and then I want to introduce a void pointer in order to solve that problem so that you can see how void pointers are used. So let's jump into our Visual Studio. Here I want to create a variable, and let's make it of int data type. So I'm going to say int, and let's call it number, like this. And I'm going to assign it a value of 5, for example. Now, what I want to do with this number variable is I just want to write it out. And because we are working with pointers, let's play with pointers some more. So I want to write out this variable using a function that receives a pointer. Let's do that. So that function is going to be of return type void, and let's call it print number, like this. And then here, this function is going to receive an integer pointer. And we are going to call it number ptr, so number pointer. Okay, now what this function here should do is it should just print out the value that this number pointer is storing. So actually the value that is stored on the address that this number pointer is holding. So in order to do that, we have to dereference this pointer. So I'm going to say star symbol and then put the name of this number pointer, and let's add an end line as well. Now, this function is finished and it is writing out the value that is stored on the address that we pass to it, and we have to pass it the address of an integer variable. So if I invoke this print number function, let's say print number, as I said, since it is receiving a pointer, we have to pass it an address, and that is going to be the address of this number variable. So let's say ampersand number. So this here is going to give us the address of this number variable. Okay, and now if I run this program, as you can see, this function here has printed out value of 5, which is the value of our number. Okay, now what happens if I want to create a character variable and then print out a character variable as well? So let's do that. I'm going to say char, let's call it letter, and let's assign it a value of a letter A. Okay, and now in order to print out this character using this same approach, I will have to create another function because this one here receives an integer pointer, and in order to print out a character, we would have to create a function that receives a character pointer. So let's copy this function here, and I'm going to call it print letter, like this, and then this function is going to receive a character pointer. Okay, and that pointer is going to be called char ptr. And then here, I just want to write out the referenced value of that char ptr. So let's invoke this print letter function. Let's pass it the address of this letter variable that we have created here. And now if I run this program, as you can see, we have 5 for this first function and then A for this second function, which means that these two functions are doing its job. But what happens if I want to print out a floating point number and then a double and then a Boolean value and a struct value? In order to do each one of those, I would have to create a function that receives that specific data type pointer. But we can solve that same problem using a void pointer because, as we already said, a void pointer can point to a variable of any data type. So let's do that. Let's create a function that is going to print out any data type. So that function is going to be of return type void, and let's give it a name print. Because it is generic, it is going to work with all data types. I'm going to give it name of print, and as we said, that function is going to receive void pointer, and let's call that pointer ptr. Okay, now because this void pointer can point to a variable of any data type, we will have to keep track of which data type we have passed inside this void pointer. And in order to do that, I'm going to use another parameter here. And that parameter is going to be of type char, and I'm going to call it type. So how this type parameter is going to be used? Well, in a situation where we pass an integer pointer to this print function, here this type parameter is going to have a value of I. In a situation when we pass a character pointer to this void pointer here, in this type parameter we are going to pass a value of C. And then if we pass a float pointer here, we are going to store an F. And then if we pass a double pointer here, this type variable should store a letter D, so that we can know how we are going to dereference this PTR pointer. So the first thing that we have to do is we have to check what this type variable is holding. So in order to do that, I'm going to use switch case like this. You can use if else as well if you want. So here I'm going to switch on this type variable like this. And what I want to do here is I want to say, in the case that this type variable is holding the value of I, that means that this here is an integer pointer. So here I'm just going to leave a comment for now. So I'm going to say handle int pointer like this. And then the other situation is going to be in the case that this type variable is holding the value of C. That means that here we have passed a character pointer. So I'm going to leave another comment as well. So here I'm going to say handle char pointer. Okay, now let's explain how we are going to handle this integer pointer and then this character pointer as well. Well, as we already said, since a void pointer cannot be dereferenced directly, but we first have to cast it into a specific data type, so into an integer pointer or into a character pointer in this particular situation, I'm going to do that. So here I'm going to say, in the case that our user has passed an integer pointer here, I will have to cast this void pointer into an integer pointer first. So how do you do that? Well, you say, please, this pointer here, so this PTR, cast that into an integer pointer. So this expression here is going to cast this void pointer into an integer pointer. So in these parentheses here, we are going to have an integer pointer. And in order to access to the address that an integer pointer is storing and write out the value that is stored on that address, we dereference that pointer. And for that, we use this star symbol. So now here we have the value that is stored on this integer pointer. And I'm going to write out that value like this. And let's add end line as well. So this here writes out the value of an integer pointer. So let's copy that and then paste it here. And here what I want to do in this C situation is I want to cast this void pointer into a character pointer, so char pointer, and then after I have character pointer here, I dereference that, and then this line is going to write out the value of our character. Okay, so now if I invoke this print function, I should get the value of this number and then of this letter as well, using only this print function. So let's comment these two for now. And let's invoke our print function. So I'm going to say print. And then the first thing that it receives is going to be the address. And in this particular situation, considering that this is a void pointer, we can pass it the address of any data type. So we can pass it the address of a integer variable or of a character variable or of a floating point variable. And in this situation, we have integer variable and then character variable. So let's use these two. So let's pass here the address of our number. That is going to be the first parameter. And then the second parameter is going to be the type. And considering that we have passed the address of an integer, let's pass the value of I as our second parameter here. Okay. And then I'm going to copy this function one more time, and this time I want to pass it the address of our letter variable, and considering that that is a character, here as a second parameter I'm going to pass C. Now I've just noticed that something is missing from our switch case, and before I say what it is, please write your idea, write your answer in the comments down below. So what we are missing in these two cases is break at the end. So here I'm missing a break like this, and then here as well. Okay, so now we have completed our switch case, and if I run my program now, as you can see, for this first line we get the value of 5, which is our integer. So this print function has printed the value of our integer, and then in this second line we have printed out the value of a character, and we have done that using this print function, which receives a void pointer, and then it receives a char variable which is called type, and we use that char variable in order to differentiate which data type we are storing inside this void pointer. Because, as I already said, a void pointer can point to a variable of any data type, but it cannot be dereferenced directly. So for that we are using this type parameter to check which data type is stored inside this pointer here. So now you have an idea on how to use void pointers, but I would actually advise you to be very careful when using void pointers. Why? Because your compiler in this particular situation does not have a way to tell you, hey, you are trying to cast a void pointer, which is actually an int pointer, into a character, or vice versa. If you're doing that, your compiler in this situation here does not have a way to know if you are making an error or not, because inside a void pointer you can store the address of any variable, so of a variable of any data type, and then you can try to cast that void pointer into a pointer of any other data type, which means, for example, in this particular situation, here we are passing an integer. So this number here is an integer, which means that here for this line of code we are receiving an integer pointer. Okay, and then in this case here we are trying to cast that into an integer pointer, and that is okay. But if we accidentally make a mistake here and we try to cast that into a character pointer, for example, like this, our compiler now does not have a way to know that we are making a mistake here. And if we run our program, look at this. We get this undefined symbol here, which is, what is this? You know, this is not the expected behavior of our program, and we did not get a compile time error, which means that this here is completely valid. So your compiler is not going to tell you that this here is an error, but it actually is a logical error. And those type of errors, so logical errors, are much harder to find inside programs. And this here is a small program, and it is kind of easy to find an error in a program that has 20 lines of code. But if you had a logical error in a program that has 20,000 lines of code, for example, you would have a very, very big problem. So again, I strongly advise you to be very careful when you are using void pointers, because as you see, compiler is not reporting an error for this situation here, but this actually is an error. So I'm going to return this to an integer pointer. Okay, so I hope that you enjoyed this video and that you learned something new. And if you did, give it a thumbs up, subscribe to my channel, and thank you for watching. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. In this video, I want to talk about pointers and arrays, and if you watched the first video of this playlist, you remember that I said that one of the common uses of pointers is using them with arrays. So in this video, I want to demonstrate how that works. So let's jump straight to our Visual Studio, and let's create an array of type int, and I'm going to call that array lucky numbers. Like this, and let's say that I have 5 lucky numbers, for example, and those are 2, 3, 5, 7, 9. Oh, that's 5 numbers already. Okay, so these here are my lucky numbers. And now I want to show you one thing. So what is going to happen if I say, for example, cout lucky numbers, and let's add end line. So what is going to be written out if I write out just the name of my array? Let's check that. If I run this program, as you can see, we get an address. But what is this address? This address here, so the name of our array is actually the address of the first element of that array. And in order to prove that, let's write out the address of the first element of this array to check if these two are going to be the same. So here I want to write out the address of the first element, which is the element with index 0. So now if I'm telling the truth, these two should be the same. So if I run my program, as you can see, indeed, we get the same address, which means, again, the name of the array is the address of the first element of that array. Now, that means that this lucky numbers name behaves as a pointer, and these square brackets here are behaving as an operator for dereferencing. So if I say, for example, cout lucky numbers of 2, I'm going to get the element that has index 2. So this here is going to be the first address, and then it is going to add 2 more addresses to that element, and we are going to get the value that is stored there. So lucky numbers name is the address of the first element. It is going to add 2 more addresses to that, so 1, 2. So this line of code here is going to give us the value of 5. Let's add end line and run our program in order to demonstrate that. And as you can see, indeed, we get the value of 5. Now there is another way to do this same thing here, and that is going to be the following way. So I can say cout, please write out this lucky numbers, which, as we already demonstrated, is the address of this first element. So I'm going to put that here. And then I can use arithmetic operators on this. So I can say, please add to this lucky numbers 2 more address spaces, and then dereference this. So we use star symbol for that. And then I'm going to add end line and these 2 lines of code. So this one here and this one here should behave the same. So if I run my program now, as you can see, we get the same value. So these 2 lines of code are doing the same thing, which means that this line of code here is using these square brackets in order to dereferentiate the element with that index, which is index 2. And we know that the indexing starts with 0, so 0, 1, 2, and we get the value of 5. And then this second line of code here uses this star symbol in order to dereferentiate this expression here. And what this expression here says, it says lucky numbers, which is the address of the first element, as we demonstrated here. So please use the address of the first element and then add 2 more address spaces to that. So the address of the first element, if I add 2 more to that, it's going to be the address of 1, 2, so the address of this one here. And then if I dereferentiate that, I get this value which is stored on that address. So these 2 lines of code are writing out the same thing. So let me very quickly show you how you can enter the values for this array and then write them out, because here we have hard-coded values. So I'm going to delete this, and I'm going to comment these 2 lines of code as well. No, actually I'm going to comment all of these because we don't need them anymore, but I'm going to leave them for you so that you can see how these are used in order to dereferentiate your array. So as I said, we want to enter values for our array now. So in order to do that, I'm going to use for loop. So I will say for, and then our for loop starts with I equal to 0, because that is the index of our first element. And then, considering that our array has 5 elements, and the last one has index of 4, we are going to run our for loop while I is less than or equal to 4. And in each iteration, we are going to increment the value of our I. Okay, and in order to enter values for our array, let's write out a message. So I'm going to say cout number. So please enter a number. That is going to be the message for our user. And then I'm going to input a value from my console into lucky numbers of I. So this here means please enter the value into our lucky numbers array to element that has the same index that our I holds in that iteration. So in the first iteration, index 0, in the second iteration, index 1, and then in the third iteration, index 2, and so on. So this for loop here is going to help us to enter the values into our lucky numbers array. And in order to show that, I'm going to put here a breakpoint, and that means that our program is going to stop its execution when it comes to this line here. So if I run my program, as you can see, it asks me to enter a number. So I'm going to say 2, 5, 7, 9, and 13. So those were 5 numbers that we had to enter for our lucky numbers array. And if I press enter one more time, as you can see, our program has been stopped in this line of code here. And if I hover over my lucky numbers, here we have values that we have entered for our array. So value of 2, 5, 7, 9, and 13, which are the values that we have entered here. So I'm going to stop my program now. Please stop. Okay. And now what I want to do is I want to use this other approach to write out the numbers that this lucky numbers array is holding. So let's use another for loop. I'm going to copy this one. Okay. And then what this second for loop is going to do, it is just going to write out these numbers. But, okay, let's use this approach for now. So I'm going to just change this to cout and then use these other redirection signs. And after each number, I'm going to add an empty space. Okay, like this. And instead of using this approach here, so instead of using these square brackets in order to dereferentiate the element on that position, let's use this approach here. So I'm going to say, please use lucky numbers, so which is the address of the first element. And then to that, I want to add the value of my I, so plus I, like this. And this is going to move, okay? So this expression here is going to help us to access all of the elements of this lucky numbers array. So from the one that has index 0 until we come to the one that has index 4. And because we don't want to write out addresses, because this here is going to give us the address, but we want to write out the values that are stored on those addresses, we will have to dereference this expression here. So for that, I will use star symbol. And I'm going to remove this breakpoint now, and I'm going to start my program to see what is going to happen. Okay, and let's enter 2, 3, 5, 7, 19. And as you can see, we get values of 2, 3, 5, 7, and 19, which we have entered. Okay, let's stop this program now. And there is one more thing that I want to show you. What is going to happen if I change this max value from 4 to 5, like this? So what is going to happen in this particular situation? Let's run our program and enter numbers again. So 2, 5, 7, 13, 15. Okay, as you can see now, here we have these 5 numbers that we have entered. So 2, 5, 7, 13, 15. Those are the ones here. And then the last one is something that we do not recognize. What is this? This is some junk number that we definitely have not entered here. So this number here is something that does not belong to our lucky numbers array. And here we have accessed someone else's memory space. So we have this result. because we changed the max value from 4 to 5 here. And as we already know, our lucky numbers has 5 elements. The last one having the index of 4, which is this one here. And then here we added one more iteration. So now we are trying to access the element with index 5. And that element with index 5 does not belong or does not exist in our lucky numbers array. So this element here, this is memory location that belongs to someone else. And we accessed that trying to dereferentiate the pointer to the element that is 6th element. So we have 5 elements in our lucky numbers array, and then if we add one more address space to that, we get this here, which is memory location that belongs to someone else. And if we just randomly change and access memory locations that do not belong to us, we can cause very, very big problems. So I advise you to be very careful when iterating through your arrays and to access only memory locations that belong to that array that you are iterating. So in the case that your array has 5 elements, those are going to be from 0 to 4, so indexes from 0 to 4. In the case that your array has 10 elements, for example, those are going to be indexes 0 to 9 and so on. So again, be very, very careful to not access memory locations that do not belong to you. So I hope that now you have an idea on how pointers and arrays go together, and as well we have seen some of the potential problems that can happen if you are not careful enough when working with pointers and arrays. So again, I advise you to be very careful when working with pointers and arrays and not access memory locations, memory addresses that do not belong to you. So thank you for watching, and I'm going to see you in my next video. Bye! In this video, I want to explain how you can use pointers in order to return multiple values from a function. So I said in the first video of this playlist that using pointers to return multiple values from a function is a very common use for pointers. So in this video, I want to demonstrate how that works. So here we are going to create an array of numbers, and then first I want to create 2 functions, and one of those 2 is going to return me the smallest number in that array, and then the other one is going to return me the largest number in that array. And then in the second part of this video, I want to show you how you can use pointers in order to get both smallest and largest number using one function only. So you can return both of these numbers, so min number and max number, using only one function, and that is going to be with the help of pointers. So let's start with this example. As I already said, I'm going to create an array of numbers. So those are going to be numbers of type int, and let's call this array numbers like this, and it is going to be an array of 5 numbers, and let's assign them values of, for example, 5, 4, minus 2, 29, and 6, for example. So those are going to be my numbers. Okay, and now let's create a function that is going to return the smallest number of this array. So I'm going to create that function here, and let's give it the return type of int, and I'm going to call it getMin, like this. And what I will need to pass to this function is going to be array, so this array here. So I'm going to say int numbers array. So this is going to be the first argument, and then the second one is going to be the size of this array. So I'm going to say int size, and we will use this second parameter here so that we know how many iterations we have to make in order to go through all of the elements of this array. So let's define this function. The first thing that I want to do is I want to create a variable of type int, and that variable is going to be called min. So this is going to be the variable that is going to hold the minimal value, so the smallest number in this array. And initially I want to assign to this variable the first element of this array. So I'm going to say that the smallest element initially is going to be the first one. So I'm going to say numbers of 0. And then we are going to iterate through all of the other elements, and each time that we find an element that is smaller than the current value of our min, we are going to store that value in our min. So let's do that. So I'm going to say for, and since we have already stored the value of our first element in our min, we do not need to iterate through that. So I'm going to say that my int initially has the value of 1. Okay. Oh, int I is equal to 1, like this. And then our for loop is going to iterate while our I is less than the size of this array. So in this particular situation, while our I is less than 5. And in each iteration, we want to increment our I, like this. So, as I already said, if we find a number on a specific position, which is in this current situation, the position with the index of I, if we determine that that number is smaller than our min number, like this, we are going to store that number in our min variable. So I'm going to say min is equal to numbers of I, so that at the end of this for loop in our min variable is going to be the smallest number of this array. So at the end of this for loop here, we can return our min, like this. Okay, so now in order to test this function here, I'm going to invoke it. Let's say get, actually I'm going to write it out. I'm going to say cout min is, like this, and then let's invoke it. Let's say get min, like this, and this get min function receives array, so let's pass it numbers array, and then it receives the size of this array, and this array has 1, 2, 3, 4, 5 elements, and you can check that here as well. So we are going to pass 5 here. Okay, and if I run this program, as you can see, it says min is -2, which really is the smallest number in our array. So that is going to be the first function. And then the second function that I want to create is going to be the one that is going to return the largest number in our array. So let's copy this function. I'm going to copy it and then just modify it a little bit. So the name of that other function is going to be get max, like this. And then that function as well will receive numbers array and the size. But here we are going to have a variable which is called max instead of min. And again, we will assign it the value of our first element. So then we iterate through all of these elements. So starting with the second element, because first the value of the first one we already have inside this variable, so we do not need to check that. But if we find in these remaining elements, if we find element that is larger, so bigger than our max, let's copy this here, we are going to store the value of that element in our max variable, like this. And then at the end, we will return our max variable. Okay, so now in order to test this function, I will invoke it as we did with this previous one. I will just say max is, and then invoke get max, like this. And I'm going to add 2 end lines here so that we have output which is formatted nicely. And if I run my program now, as you can see, it says min is -2 and then max is 29, which is correct. So let's explain one more time the algorithm that we are using here in order to determine the biggest number of our array. So here in this first line, I say that the biggest number is the one with the index 0, so the first one. And then here we iterate through all of the remaining elements, and that is from the one with index 1 until the last one. And if we find that any of those remaining numbers is greater than our max number, then we say that our max number is equal to that number. So at the end of this for loop, we will have in our max variable the largest number of this array here. Okay, and we have accomplished to get our min number and then our max number using these two functions. Oh, I'm sorry. So using this get min and then get max function as well. So now what I want to show you is how you can use one function only to get both min and max number. So let's do that. Let's create a function which we will name void get min and max, like this. And this function is going to receive, like these two previous functions, our numbers array and the size of the array. And then, considering that we want to return two values from our function, we will have to pass those two values by a reference, which means we will have to pass the addresses of the two values, and then this function here is going to change the value that is stored on those two addresses, and this function here, our main function, is going to have the access to those two addresses as well. So once this function here assigns the value of min and max numbers to those two addresses, our main function is going to be able to access those values. So as I said, let's pass to this function as well int min, like this, and then int max. So we are receiving here pointer to a min number and then pointer to a max number. Okay, so the job of this function will be very similar to the jobs of the two functions that we just created. So I will just copy this and then paste it here. And once more, we are iterating through all of the numbers of our numbers array. And then here we say if you find any number which is greater than our max number, and here we have an error which says operand types are incompatible, so int and int pointer, which means that here we have to dereference this pointer using the star symbol. So if you find any number which is greater than our current max, please store that number inside our max, like this. And then I'm going to copy this code one more time for our min number. So I will say if you find any number which is smaller than our min number, like this, please assign that number to my min number, like this. So this is going to be the work that this function will do. And considering that this function is receiving these two, so min and max, as pointers, this means that this function is directly going to modify the values that are stored on these addresses. And those same addresses are going to be available in our main function, which means that once this function changes the values that are stored on our max and our min address, this main function here will be able to access those changed values. And using pointers, in that way we have achieved to return multiple values from our function. So let's invoke this get min and max in order to test what I just said. So I'm going to comment these two lines of code because we do not need them anymore. And because here we have to pass min and max, we will have to create those two variables here as well. So I will say int min, and as we did before, I'm going to assign to this min the value of my first element, like this, okay? And then I will create max variable as well and assign to my max variable value of my first element as well. And now let's invoke this get min and max function. So let's say get min and max, and let's pass it parameters that it needs. So the first one is numbers array, so I will say numbers, and then second parameter is size of that array, so 5, and then it expects to receive two pointers, so min and max, and we will have to pass addresses of our min and then address of our max as well, like this. And this here is called passing a parameter using a reference. So that means pass an address of a variable to your function rather than passing variable itself, because then if you don't pass an address, your function is going to create a copy, and whatever changes your function makes with that copy, you will not be able to see those changes in your main function. So in this way, we are passing addresses, which means that this function here is operating on the original addresses, which this function here is accessing as well. So when this function here changes the values that are stored on those addresses, this function here will know. So that means that now if I try to write out, I will need to add semicolon here at the end. Okay, so that means now if we try to write out our min like this, min is, and then min, and then if we try to write out our max as well, max, we will get values of -2 and 29. At least we expect to get those two values if this function is working correctly. So if I run my program, as you can see, we really have values of -2. Let me just collapse this. So we really have values of -2 and 29 as the smallest and the largest number in our array. And we have achieved that using this pass by a reference. So by passing addresses of our variables to our function, which our function then changes the values that are stored on those addresses, and since this main function as well has the access to those same addresses, that means that our main function can see the changes that have been made on those addresses. So I hope that now you have an idea how to return multiple values from a function using pointers. So if you enjoyed this video, if you learned something new, give it a thumbs up and also subscribe to my channel. Press the bell icon as well. Thank you for watching, and I'm going to see you in my next video. Bye! In this video, I want to talk about dynamic arrays. So you should already be familiar with the idea of arrays and the concept of fixed arrays from my previous videos. But for those of you that really want to understand the need for dynamic arrays, I will go through some of the advantages and disadvantages of fixed arrays so that you can really understand where the need for dynamic arrays arised. So we said that an array is type of collection which stores elements in continuous memory. Now that means that it stores elements one after the other. So if I do this, for example, if I say let's create an integer array of 5 elements and let's call that array my array, like this, your computer in the background will do the following. It will give to this array here 5 containers of type int, and those containers will be one after the other in memory. So that means because the array stores data in a continuous memory, so one after the other, accessing that data will be very, very fast. So because the name of the array is the address of the first element of that array, when you specify the name of the array and then you give it the index of the element that you want to access, it is going to be very fast to move from that first element until that position that you specified, so until the element that has that index. Whereas if you use some other collection type like linked list, for example, which stores data in non-continuous memory, which means in a random places in memory, and then each element contains a pointer to the previous one and to the next one, accessing elements in those type of collections would be much slower. So if you wanted to access 5th element of linked list, you would have to traverse the first 4 elements and then get to the 5th one, because they are stored in non-continuous memory, meaning they are randomly in your memory. So, as I already said, accessing elements of an array is a very, very fast operation. But because your array stores data in continuous memory, this has certain disadvantages as well. So, what happens if you want to insert or delete an element in the middle of the array, for example? So how can you insert or delete an element in the middle of the array without breaking that continuousness, if I can say it like that. So you get the point. That means that the operation of inserting and deleting elements in an array is going to be much slower than inserting elements in a linked list, for example. And if you want me to do a video which is related to differences between linked lists and arrays, for example, write it in the comments down below and I will make it in the future when I find time. So again, if you are not familiar with the basics of arrays, I recommend you to watch my first video, which is related to arrays and pointers, which I will link here, and then you come back to this one. So those were some advantages and disadvantages of arrays, and it will be up to you to decide which collection you want to use. However, here I want to give you the biggest disadvantage or the biggest obstacle that we encountered so far when working with arrays, and that is the following. So the size of the array had to be constant, which means that the size of the array had to be known before we even started our program. So we always kind of wanted to do this. So we wanted to say int size, and then we wanted to ask our user to enter the size. So please enter the size for the array. And then after our user enters the size for the array, we wanted to create the array that is of that size that our user specified. However, we get the error. As you can see here, it says expression must have a constant value, which confirms what I just said, which is that the size of the array had to be known at compile time. So the size of the array could not be changed once we declare it, and we had to declare it before we even started our program. So this problem was without solution so far, but surprise, surprise, if you know how to work with dynamic arrays and dynamic memory, you can very easily create an array in runtime. So in C++, there are two keywords or two commands which allow you to allocate and deallocate dynamic memory, which means to get yourself dynamic memory when you need it, and then free that memory once you don't so that it can be reused. That is what allocate and deallocate means. And those two commands are new and delete. So new allocates memory, as you may guess, and then delete deallocates that memory or freeze it once you don't need it. So let's see how we can use this information that I just gave you on our example. So instead of doing this here, I will comment it because we do not need it. Instead of doing this, what I will do is I will create a pointer like this, and let's call that pointer my array. And what I want to assign to this pointer will be the following. I will say, please make this pointer point to new integer array, and the size of that array will be this size that our user entered, like this. Okay, and as you can see, our compiler is fine with this expression here. We do not have an error. So this new keyword has allocated an array of this size that our user has specified. And that array, the address of the first element of that array, is stored in this my array pointer. So if I build this code, as you can see, we do not have compile time errors. So what I want to show you now is how we can enter elements for this array and then how we can write them out. And this is array, again, this is array which is created at runtime. So our user will specify the size of this array, which is something that we were not able to do before we learned how to use dynamic arrays. So in order to enter elements for this array here, as we already know, we will be using for loop. So I will say for, please iterate from the element which has index 0 until you come to the element that has the index of this size. Okay, and then in each iteration increase our counter by 1. And what I want to do is I want to write out a message for my user. So I will say array, and then let's add index of the current element, index that our user is entering. So I, like this. Okay, and then what I want to do is I just want to enter an element on that position that we are currently iterating. So I will say my array of I, like this. So using this code here, we should be able to enter elements in this array here. And then in order to write these elements out, what I will do is I will use another for loop. So I will just copy this one and then paste it here. And in this particular situation, I just want to write out. So I will use cout command and then these other redirection signs. So I just want to write out all the elements of the array, and I will add a few empty spaces after each element so that we have a nicely formatted output. So this loop here should write out the elements of our array. And if I start this program now, as you can see, it asks us to enter the size of the array. So let's say 5, for example. And now we are entering element with index 0. So let's say 2, 5, 7, 9, and let's say 11. Okay, and as you can see here, we have the elements of our array written out. And we wouldn't be able to do this if we didn't know how to work with dynamic arrays. So let's stop this program. And there is one more thing that I want to mention, and that is following. These square brackets here are only one way to dereference your array. Another way to dereference the array or to access the element on a specific position is the following. So the other way to access the element on a specific position would be using this asterisk symbol, and then here you say my array plus I. Now, because the name of the array is the address of the first element, here you have the address of the first element, and then when you add a certain number to that, it will move that many spaces in memory and then access the element on that position. And when you dereference that, you will get the value of that element instead of its address. So here is one way to dereference your array, and then here is another way to dereference your array, and you can use whichever one you prefer. And if I run this program again, just to demonstrate that it works the same, let's say 3 and then 1, 5, 10. Okay, we get 1, 5, 10 as the elements of our array. One very important thing that I mentioned at the beginning is that we have two commands for working with dynamic memory. And one of those two commands is new. So we said that new is a command which will allocate memory for us when we need it. And then another one is going to be delete. And delete is a command which will deallocate that memory when we do not need it so that it can be reused. Now, using dynamic memory comes with a responsibility, and that responsibility is the following. Each time that you allocate memory when you need it, you will have to deallocate that memory once you don't, so that that memory can be reused. So that means that each time that you write new command, you will have to write delete command once you don't need that memory anymore. So I will demonstrate how can you deallocate the memory that we have allocated for this my array. So let's say that here in this line of code, we do not need our array anymore. So how can I deallocate the memory that I allocated for this array? Well, using delete keyword. And I will say, please delete the memory that I allocated for my array, which is called my array, like this. And you have to specify these square brackets because that is the way that you allocated memory. So here you said, I want new array. And then here you have to say, please delete that array. And a good practice is to do the following as well. So you can say my array is equal to null, like this. And let me collapse this. So this here is going to assign the value of null to your array. So your array will not point to anything, to any address at this line of code. So why do we do this? Because in the previous line of code, we have deallocated this array here. And now in this line of code here, your array will point to a location in memory which does not belong to you, so it does not belong to your program. And because of that, because we do not want to cause some accidental crashes or problems in our program, by having this array pointing to memory locations which are not ours anymore, it is a good practice to say that our array is now equal to null, which means that it is not pointing to anything. So, as I already said, and I repeat again, when you use dynamic memory, each time that you write new, you will have to write delete that corresponds to that new. So here I have allocated an array, and here I am deallocating that array. So I hope that this video was helpful and that this video helped you understand what are dynamic arrays and how they work. And now that I have explained this, it opened the whole world of new possibilities and new things that you can do with dynamic arrays. And I will leave to you to play and discover those new things until my next video, of course. So thank you for watching this video. Give it a thumbs up if you liked it. Subscribe to my channel, click the bell icon as well, and I'm going to see you in my next video. Bye! In this video, I want to talk about a topic that confuses many students, and that is the topic of multidimensional dynamic arrays. And the topics like this one are the reason why many people step away from learning C++, and they believe that learning C++ is hard. But what I think is that many of those people never actually had the opportunity to have this explained in a very simple way. So that is what I will try to do in this video. So with the help of Excel, I will try to draw what are multidimensional dynamic arrays and how they work. And I hope that at the end of this video you will have it pretty clear and you will be able to create and work with your own multidimensional dynamic arrays. So what a multidimensional array is, in simple words, it is an array of arrays. And in this video you will learn how to create two-dimensional dynamic arrays. And in order to be able to understand this topic, you should be familiar with the topic of dynamic arrays, which is a video that I already did on my channel, and I will link it here, so make sure to watch that video before watching this one. So I will very quickly remind us all of how dynamic arrays work, and then we will see how we can use that knowledge to understand multidimensional dynamic arrays. So let's create a visual representation of a dynamic array in our Excel sheet. So let's say that it will be an array of 4 elements, like this. This is our array, and the indexes of these elements start with 0 and then 1, 2, 3. So these are the indexes, and then the address of this first element will be, for example, 0000AA, like this. And this address here, it is the address of the first element, but it is the address of the array itself as well, and you should be familiar with that. So this here is our dynamic memory, and then on our stack, which will be here, let's create our stack. So this here will be our static memory. Here we will have to create a pointer variable which will hold the address to this element here, or actually the address to the array itself. So I will create a variable, let's call it ptr1. So this is going to be our pointer 1, and as we already said, that pointer will hold the address of the first element of this array. Let's copy that address like this, and then we will store that address in our ptr1. Now, if we wanted to create more arrays, by the knowledge that we have so far, we would have to copy this. And then let's paste it here, and let's create one more array like this. So now we have 3 dynamic arrays, and the first element of the first array has the address of 0000AA, and then this one here, let's say that it has the address of BB, for example, and then this one here has the address of 0000CC. And to be able to access these arrays, we would have to create on our stack 2 more pointers. So let's do that. Okay, so our pointer 2 will hold the address of the second array, which is 0000BB, and then our pointer 3 would hold the address of our third array, which is 0000CC, like this. Now, with this, we have created 3 dynamic arrays. And in order to create those 3 dynamic arrays, we had to create 3 pointers. So those are these 3 here, and this is something that you should already be familiar with. So you should already know from my previous video how to create a dynamic array. Now, one thing that I see here, and that is a problem, is that if we wanted to create 4 or 5 or 100 of these dynamic arrays, we would have to create that number of pointers on our stack, which means that this part here is not dynamic. Only this part here is dynamic, because here our user determines how many elements this dynamic array will have, but for each of these dynamic arrays, we have to manually create a pointer on our stack, which will hold the address of that array. Okay, now, what happens if I want to move this part here to our dynamic memory as well? So let's do that. Let me cut it from here, and then I will paste it here, for example. So now I have moved this part to dynamic memory as well, and as you can see here, this kind of looks like an array as well. So that means that this first element, if we look at this as an array, the first element will have index of 0, and then second will have index of 1, and then third will have, oh, this won't move. Third will have index of 2. Okay, so this is an array that has 3 elements, and the first element, for example, has the address of 00EEEE, like this. So now this part here is dynamic, and then this part here is dynamic. And in order to be able to access this array here, what we have to do is on our stack, which is this part here, we will have to create a pointer which will hold the address of this first element. So let's do that. Let me just, okay. Now, as I already said, on our stack, we will have to create a pointer which will hold the address of this first element. So let's call that pointer table, for example, and this table will hold the address of this element here, which is 00EEEE. And this table, because it holds the address, it should be a pointer. But one thing to keep in mind is that this variable here is not a simple variable, but this here is a pointer as well, which means that this table will not be a simple pointer, but it will be a pointer to a pointer. And you indicate that using 2 asterisk symbols, because one is just a pointer, and then 2 mean a pointer to a pointer. Why? Because this table holds the address of the element, which is this one here, and that element is pointer as well. Okay, now if we look at this here, as you can see, we have one array that represents the number of rows that our table will have. Okay, so 1, 2, 3, and then for each one of the elements of this array here, we create a separate dynamic array like this. So this here will be our table that has the number of rows that our user defines, and then however many columns our user defines as well. And in this particular situation, it is a table that has 3 rows. So these are 3 rows, and then 4 columns. So let's now translate this to our C++ code. And because we said that now our user defines how many rows this table will have and then how many columns as well, that is the first thing that I will do. So I will create 2 variables. Let's call them int rows and columns. And then I will ask my user to enter how many rows and how many columns he wants this table to have. So let's do that. Cin rows, and then columns, like this. Okay, now after our user has entered how many rows and columns he wants, what I want to do now is this part here. So this part here, this is our first step, and then this here is going to be our second step, and this part here will be the third step. So this part here will be the following when translated to C++ code. So here, as I already said, I create a pointer to a pointer, which I will call table. So I will say, please create an integer pointer to a pointer, because here we will store integer values. You can create a character or a double or float, whichever one you want. I want to create integer pointer to a pointer and call that table like this. Okay, so we are done with this first part here. And then what this table pointer to a pointer will point to is going to be this array here. So I will say, please create a new integer array that has this many elements. So the number that our user has entered for this rows variable, because this rows variable holds how many elements this array here will have. But as you can see here, we have an error, and that error is happening because this here, which is this array here, is not just a simple integer array, but it is an array of pointers. So here you will have to indicate that. So you will have to say, please create an integer array of pointers. And as you can see, now our error has disappeared. And with this line of code here, we have created this array here. Now, our third step is going to be that for each element of this array here, we would have to create a separate dynamic array. So this first element will hold the address of this dynamic array, and then this second element holds the address of this array, and then this third, the address of this array here. So what I will have to do is I will have to iterate through all the elements of this array, and for each one I will have to create a separate dynamic array. So let's do that. So I will say for int I is equal to 0, and then I is less than the number of rows that our user entered, and in each iteration increment I. So in this particular situation, our number of rows is equal to 3, but you can have as many as you want. So what I want to do in each of these iterations is I want to create for each one of these elements a separate dynamic array. So I will say table of I is equal to new integer array that has this many elements. And that is the number that we stored in our columns variable like this. And with this code here, we have successfully created these dynamic arrays. Now, how do you access elements on a specific position of this table here? For example, this one or this one or this one. So in order to do that, let's say, for example, table of row 1 and then column 2 will have the value of 88. Now, what this code here, what this line here will do is the following. So this part here, it says, please give me the table variable, which is this one here, and it is a pointer to a pointer, which holds this address here, so 00EEEE, and that address is the address of this element here, so the address of this array. And here we say, please give me the element of that array that has index 1, which is this element here. So it is the element that stores the address of 0000BB, which is the address of this array here. And this second part says, please give me the element of that array that has the index of 2, which is this element here. So here we will store the value of 88. So that is what this line of code here will do. It will store number 88 to this position here. So this line of code here will store this number at the element that has row index 1 and column index 2 of this table. So this here is the row with index 0, this here is the row with index 1 and then 2. So we are storing at this row, and then column index 2 is this one here. So here we store number 88. One thing that we said as well in my previous video is that each time that you allocate dynamic memory, you have the responsibility to deallocate that memory when you don't need it, which means each time that you use new keyword, you will have to use delete keyword when you don't need that memory anymore. So now is the question, how do we deallocate all of this memory that we have taken? So in order to do that, what I want to do is I want to show you something. If for some reason we lose this address here, so the value that is stored in this table pointer to a pointer, we we will never be able to access all of these elements that we have created in our dynamic memory. So that means that we will not be deallocating this first. And then if we for some reason lost this, the value of our 0000AA, for example, that means that we would never be able to access this array here. So we would never be able to deallocate this memory. So that means that this is not going to be deallocated first as well. Now, allocation of this memory here went as follows. This was the first step. So this was the first thing that we allocated, and it is this code here. And then we allocated this. So that corresponds to this part here. And then the last thing to allocate was these arrays here, and that corresponds to this part of the code. And the allocation of this memory will go the other way around, which means that first we will deallocate this, and then we will deallocate this, and then this will be the last thing that we will have to worry about. Now, in order to deallocate this, the process will be almost the same as the one when we allocated it. So I will copy this for loop and then paste it here. But what I want to do in this particular situation, so when deallocating, is instead of creating a new dynamic array for each table of I, is I want to delete that array. So for each element of this array here, I want to delete the corresponding dynamic array. So I want to delete these three arrays. And in order to do that, I will say, please delete the array that my table of I is pointing to. Now, what this code here will do is for this element here, it will deallocate this array here. So let's delete that. And then for this element here, it will deallocate this array. And then for this one, it will deallocate this array here. So now we have successfully freed this memory that we have taken here. Now, after we have done this, after we have successfully deallocated our first step, which was here, this part here will be our second thing to deallocate. So here I will say, please delete the array that my table variable is pointing to. So this line of code here will deallocate this part here. So I will say, please delete that. We do not need it anymore. Okay. And then our third step, which is the last one, will be to null this value here. Why? Because we have just freed the memory that was here. So we have deallocated that. Now someone else might be using this memory here, and we really shouldn't keep the address of someone else's memory. So we should make this a null value like this. And in order to do this in our code, I will just say, now my table will hold the value of null like this. And this will prevent some potential crashes and problems in your application. So I hope that this video helped you understand multidimensional dynamic arrays a bit better. And if it did, please give it a thumbs up and subscribe to my channel, because that helps me to reach more people and hopefully make programming a little bit easier for them as well. Thank you very much for watching, and I'm going to see you in my next video. Bye! So I get a lot of messages, a lot of questions on my Instagram, on Twitter, and then here on YouTube as well in the comments, where you ask me for an opinion or for advice on certain errors that happen to you in programming. And I try to answer as many of those as possible, but it's just not possible to answer to all of you, and I'm very, very sorry. But I thought that it would be a good idea to make a video related to that so that all of you can see it. So here I am, I'm making that video right now. So in this video, I will be reviewing some code, and we will see some errors that can happen and that do happen very often. And I'm going to do that both manually, and then I want to show you a very cool tool which is called PVS Studio. I'm going to leave details in the description down below so that you can check it out for yourself. But what PVS Studio is, it is static code analyzer. So it is basically a tool that reviews your code and helps you detect bugs and errors and security weaknesses in your code. So in the case that you need another pair of eyes to look at your code and give you a few tips and recommendations, it is a great tool to use. and you can get it as a team license for teams up to 9 people, or you can get an enterprise license for bigger companies, bigger departments, or you can even request a free license if you are a student, if you are working on some private projects or on some open source projects. And then one very cool thing is that it is not only used to analyze C++ code, but you can use it for C and then C# and Java as well. And I am wondering, guys, which team are you in? Are you team C++ or are you team C# or Java or C? I'm very curious to read your answers, so please write me in the comments down below. And if you ask me, I'm definitely team C++ and then team C#. Those are just two of my favorite languages ever, but I am very curious to read what you will answer to this question. So I'm going to leave all the details about PVS Studio in the description of this video so that you can check it out for yourself. And let's jump into the coding part right now because I am very, very excited to do this. Here I have created a new project and I have this program that does basically nothing. So what I want to do is I want to check if everything is okay with this code so far. So if we have made any errors so far. So I'm going to click on extensions and then PVS Studio, and here you have multiple options. You can check your current file, you can check open files, or you can check your project, selected items, solution. I'm going to select this first option, so I'm going to check this current file, and you get this window here. And as you can see, we have one error, and that error is that my license will expire in 5 days. Okay, so that is not error which is related to our code, so we are just going to ignore it, so we don't have code errors so far. And let me show you how you can install this tool very quickly. So you click on extensions and then manage extensions. Okay, and then here you can search for PVS Studio like this. Okay, great. It is this one here. So PVS Studio is a tool for detecting bugs and security weaknesses and so on. Okay, so you will click download here and your download should begin. I'm not going to do that right now because I already have it, but once it is downloaded, the installation is pretty simple. So it's basically next, finish installation. So that should be simple. Okay, now let's close this window here. And as you could see, we don't have any errors with this code so far. So let's write some code and let's create some errors now. So let's create an array of type int, and I will call it saved money, and that will be an array of 5 elements, and I want to initialize those elements here. So the purpose of this array is following. Let's say that I want to save some money each month, and I want to store that data in this array here. So I'm going to save money for 5 months, and I will store how much money I have saved each month inside this array here. So for example, the first month I have saved $100 or euros or whatever, and then second month I have saved 200, and then 300 and 400 and 500 fifth month. Okay, so this is our array. Now what I want to do with this data here is I want to sum it after 5 months. I want to know how much money I have saved in total. So I'm going to create a variable of type int, and I will call it total like this, and I will initially give it a value of 0, and then I will iterate through this array here. So I will say for int I is equal to 0, and then I is less than or equal to 5, and then I plus plus. And what I will do inside this for loop is I will say that my total will hold whatever my total was previously holding plus current value of how much money I have saved in that month. So saved money of I. Okay, now after I have done this, I will just write out how much money I have in total. So I will say total, and then this value that is stored inside this variable here. Okay, now if I run this program, let's see what will happen. Well, it says that in total I have minus 8 billion something, very, very big number. So I have tried to save each month, and then at the end I have minus $8 billion, you know, so that does not make any sense. So here we have a logical error. Okay, so let's see what is this error that is happening. So let's click on extensions and PVS Studio, check current file, to see what kind of error PVS Studio sees, and it says array overrun is possible. The value of I index could reach 5. And if I double click on that, it will take me here. And this part of code here is underlined, and this is actually our compiler. Our compiler is underlying this, and it says that, okay, it says index 5 is out of valid index range of 0 to 4. So this here, this situation here, says that this I is out of range of valid indexes that this array here can have. And if you are familiar with arrays, you know that indexing of an array starts with 0. So the first element has index of 0, and then 1, 2, 3, and 4. So valid indexes for this array here are from 0 to 4, and here we have accidentally written that this I is less than or equal to 5, and that is making a problem. So if I delete this part here, so if I say that my I is just less than 5, this error should disappear. So if I click on PVS Studio and then check current file, the error should disappear. Okay, it has disappeared now. So if I run my program, this program is behaving as expected. So this is one thing that very often happens. You can accidentally write less than or equal to, and then you can get a very, very big logical error. Another thing that can happen is if you're typing very quickly and if you lose concentration for a moment, and here instead of incrementing, you decrement this counter. So you say I minus minus, you should get an error as well. So if I try to build this program, let's see what our compiler will tell us. So here in this error list, it says ill-defined for loop counts down from minimum. So that's kind of helpful information. And then let's read this other warning. It says reading invalid data from saved memory. The readable size is 20 bytes, but minus 4 bytes may be read. So this is not really helpful for someone who is just starting. And then this third message, it says index minus 2 billion something is out of valid index range 0 to 4. Again, this is not really helpful for someone who is just starting. So let's see what our PVS Studio has to say. So I'm going to click Extensions, PVS Studio, check current file. Okay, and this first error here says the condition I less than 5 of for loop is always true. So this is actually a helpful message, and if I click on this, I will be taken here, and it says that this condition here, I is less than 5, is always true. But why is it always true? Because we have started counting at 0, and then we try to decrement that value in each iteration, and doing that, we can never reach this condition here. This condition here will never become false. So that means that here we have created an infinite loop. And here our PVS Studio says, consider inspecting this for operator. So consider inspecting this for loop here, because it will not be executed at all, or it can be executed incorrectly. And in this particular situation, it is going to be executed incorrectly. So it is going to be an infinite loop, which we don't want in this particular situation. So I'm going to correct this error here. So I'm going to return it to I++. But that is sort of a help that you can get from PVS Studio. And this here is a pretty simple program because it has just a few lines of code where all the bugs can potentially happen. But imagine working on a very, very big project and then something like this happens. So imagine something like this happening on a program that a bank uses. So you are trying to save money for a couple of months, and then the program says that you are in debt, that your balance is minus 2,000 or 20,000 or something like this. So this can create very, very big issues. And in this particular situation, if you have a bug like this, you will want to have all the help that you can get. And sometimes that can be just the help that you get from your compiler, or if you have a very, very big problem, you will definitely benefit from tools like PVS Studio, which will give you some additional information on that situation that is happening and on that problem that you are having. And then there are other situations where you can have very, very big problems, but your compiler will not be helpful at all, because your compiler will not be able to see those potential bugs that you are creating inside your code. So in order to demonstrate that, let's delete all of this code here, because I will not need it anymore. And what I do need is to create a function here. So let's create a function of return type void, and I'm going to call it my function, like this. Okay, and what I want to do inside this function is I want to create an integer pointer, PTR. So if you're not familiar with the topic of pointers, make sure to watch the playlist that I will link here. It is the playlist where I explain pointers in C++ because it is one of the most important topics in C++, and it is the example that I will be using here. So I have created an integer pointer, and I'm going to say, now you will point to a new array of integers, and that array will have 5 elements, like this. Now, what do I want to do with this array? Well, let's do something very simple. Let's say ptr of 2 will hold the value, okay, it will hold the value of 10, like this. And then let's just write out something. Let's say, hi, I am equal to, and then ptr of 2. Okay, so this here is pretty simple example that does basically nothing important, nothing useful, but I will use it to demonstrate a very, very big issue that can happen in this situation. So I'm going to invoke this function here. So I'm going to say my function, like this, and I have successfully invoked this function. So if I run this program, it says, hi, I am 10. So nothing unexpected happened. Or did it? Okay, if I inspect my errors list, it says that I don't have any errors. So if you ask a compiler, it will tell you that everything is perfectly fine. So let's now ask PVS Studio. Here it has already detected 2 potential issues, but you can click PVS Studio and then check current file just to be sure. Okay, and it says visibility scope of the PTR pointer was exited without releasing the memory. A memory leak is possible. So what we have done here in this program is we have created memory leak. Where? Here. So here we have said, please give me, in my dynamic memory, give me an array of 5 integers. And this is going to be done in dynamic memory. So once this function is finished, once this function ends, we are going to lose this PTR. So we are going to lose the address of the first element of this array here. So here, if I try to do something like PTR, I cannot access this variable here anymore. This variable has its scope, and that scope is inside this function here. And once this function exits, we are going to lose the address of this array here, which means that we will not be able to deallocate this memory here. Now let's delete this. Okay, here, as you can see, this memory leak is not a big memory leak. Here we are leaking 5 integers, so we are leaking an array of 5 integers, and that is not very big problem. But usually what happens in real life is that you are not creating an array of 5 integers. Usually you are creating things that require much more memory than just an integer array of 5 elements. So here, as I said, we are leaking 5 integers, but imagine a situation where you're creating an array of 5,000 or 50,000, and not integers, but objects of type user, like this. And this user has some pretty heavy data in it. For example, it has some images and things like that. So here you are creating 50,000 users. And to make things worse, imagine not invoking this function only once, but imagine invoking this function in a for loop, for example. So invoking it 100 times or 1,000 times or 100,000 times. That is going to be a huge memory leak. So what this line of code here does is it asks your operating system for dynamic memory. So it says, please, can you give me new memory? So can you give me dynamic memory that I need to store this data here? And your operating system gives that memory to your program. So it allocates that memory for your program. And then once this function here finishes, you will lose all the variables that you have created inside that function. And that is this PTR variable here. So that means that the address of this array here, which was stored inside this PTR variable, is lost now, and now you will not be able to deallocate this memory here, which means that you will not be able to say, okay, now I am done with this memory, which is a lot of memory, and now I'm going to return that back to my operating system, because I don't have unlimited amounts of memory, and my operating system maybe would like to give that memory to some other program. So once this function here ends and you don't deallocate this memory here, you are leaking that memory. And that is exactly the error that you have here. It says a memory leak is possible, whereas your compiler here said expected a type specifier, which is error that we have here because it does not know what is this user. So I'm going to return this back to int. Okay, now that error has disappeared, but your compiler does not know that you are leaking memory here, whereas your PVS Studio analyzer here says that a memory leak is happening. So how do you fix this error here? Well, for each new, you need to have delete. Again, you need to watch my C++ pointers playlist in order to understand pointers if you don't understand this already. So as I said, for each new, you need to have delete. So I'm going to say delete, and let's delete this PTR. Let's see what is going to happen now. So if I click extensions and then PVS Studio check current file, it says the memory was allocated using new array type operator, but it was released using delete operator. And then it gives you a recommendation here. It says use delete array pointer instead. So here we are trying to allocate memory for an array, but we are not deleting that entire array. So here we are leaking memory again. So here I'm going to use these square brackets in order to indicate that I want to delete this entire array that I have allocated in this line of code here. So now we shouldn't be leaking memory anymore. So let's check that out. I'm going to say PVS Studio check current file, and let's see. We have that error that we previously had, which is your license will expire in 5 days, but we do not have memory leaks anymore, which is great. So errors like this, memory leaks, are very common when you work with pointers in C++, and these memory leaks can create huge problems if you have them in your code. And as you could already see, in most cases you cannot really count on your compiler to tell you that you are leaking memory, because in most cases it will not even be able to see that. So tools like PVS Studio can be very helpful in those situations. You could see all those little tips and recommendations that we had from PVS Studio that helped us to fix issues that we had related to leaking memory. So those were some topics that I wanted to address in this video, because many people, when working with pointers, will come across problems that they will not be able to fix, or they will not even be aware that they have those problems, that they have memory leaks, until it gets to the point where it is unmanageable and they have very big problem, they have huge problem. So if you have any more questions that you would like me to make a video on, please leave those in the comments down below. And if you like this type of video, please give this video a thumbs up so that I can know, and I will make more videos like this in the future if you want me to. So thank you very much for watching this video, and I am going to see you in my next video. Bye! Hi everyone, and welcome to my channel. In this video I want to teach you about function pointers in C++. Many beginners think that function pointers are extremely hard to understand, and to be honest, the syntax is one of the ugliest things that you are going to see in C++ language. But in this video I decided to simplify it and to make it understandable for every single beginner. So in this video you are going to learn how to use function pointers and why they exist, what is their purpose. The first thing that I want to explain related to function pointers is what are function pointers, and then later in the video I'm going to explain what is their purpose, why do they exist. And I'm also going to leave timestamps in the description that you can use in order to navigate yourself to the desired part of the video, but I highly recommend you to watch the entire video if you really want to understand what are function pointers. So In order to understand what are function pointers, you first need to understand what is a pointer. And in the beginning of this playlist, in the first video, we already said that a pointer is a special type of variable that is used in order to store the address of another variable. Now, a function pointer is very similar, but instead of storing the address of a variable, a function pointer stores the address of a function. So let's demonstrate how that works in Visual Studio. So let's create a function of return type int. Let's call it getNumber. And from this function, I just want to return number 5, like this. And it is very easy to predict what is going to happen if I say getNumber and then I run my program. Okay, we get the value of 5 written in our console. Okay, now, one question that I have for you is what is going to happen if I remove these parentheses? So what kind of output do you expect to get in the console? Write me in the comments. So if I run my program now, as you can see, we get an address. So what kind of address this is? This is the address of our function. And now that we learned that the name of the function will give you its address, what we can do is we can create a function pointer and then we can assign the address of that function to a function pointer. So let's stop our program and let's do that. I am going to remove this line of code. I don't need it anymore. And now I'm going to show you how you can create a function pointer. The syntax is pretty hard, so pay attention. The first thing that you need to do in order to create a function pointer is use these parentheses, and then inside parentheses you will put asterisk symbol, and you will give the name to your function pointer. So let's call it funcPTR. So function pointer. That is the first part. The second part is to put the return type of your function in front of the name. So here, since I want to point to this function here, the return type is int. So I'm going to put int here. And then the third part is to put the parameters that your function receives after the name of your function pointer, and that is here. So you are going to put parentheses, and inside these parentheses you would put the list of parameters that your function receives. But since this function here does not receive any parameter, these parentheses are going to be empty. Okay, and with this we have successfully created a function pointer that can point to any function that returns int and it does not receive any parameter. And that is, for example, this function here. So what I can do now is I can say that my function pointer will point to getNumber function. And as we already saw, this getNumber function will give us the address of this function here. So what I can do now is I can use this function pointer in order to invoke this function. So I can say cout funcPTR like this. So the approach is absolutely the same as invoking that function directly, but instead of using the name of the function, you just use the name of the function pointer. So if I run the program, as you can see, we are going to get the value of 5, but we have invoked this getNumber function by using a function pointer. Okay, so let me show you one more time how you can create a function pointer, but this time I want to show you how you can do that for a function that actually receives parameters. So let's delete all of this code like this, and let's create another function. So let's create a function that returns int, let's call it add, and this function will receive int a and then int b, and the task of this function will be to sum these two numbers and then to return the result. So I'm going to say return a plus b, like this. So how can we invoke this function by using a function pointer? Well, let's again repeat how we can create a function pointer. So one more time, you use parentheses, and then inside parentheses you are going to put asterisk symbol to indicate that you want to create a pointer, and then you will give a name to your pointer. You will call it funcPTR, for example. And then two more things. The first one is to put the return type of your function in front, so int, because we want to point to this function here. And then the second part is to put parameters after the name of your function pointer. So here, and here inside these parentheses, I will put int and then int, because this add function receives two parameters, and those are integer and integer. So now we have created a function pointer that can point to any function that returns integer and receives two integers. And that is this function here. So I can now say that my function pointer will hold the address of add function. And if I want to invoke this function, there are two ways to do that. So I can either say cout add, and then let's pass two numbers. Let's say, for example, 2 and 3. Let's add end line. And then second way to invoke this same function is by using this function pointer. So I can say cout and then funcPTR, and here I'm going to use the same approach of passing parameters like I did here. So I'm going to say, for example, 3 and 4. And let's add end line here as well. So if I run my program, let's see what is going to happen. Okay, for this first line, we get the result of 5. So 2 plus 3 is 5. And then for this second line, we get the result of 7. So 3 plus 4 is 7. So this is how you can create a function pointer, and then this is how you can invoke that function by using its function pointer. Okay, now that you have seen and understood what I just explained, your question might be, Saldina, why would anyone want to create a function pointer just to be able to invoke that function? Because it is so much easier to do that directly. And the answer to your question is you are absolutely right. But this is not the purpose of function pointers. This is not the reason why function pointers exist. So let's talk about the real purpose of function pointers, why they exist, and when we can use function pointers. One of the most common uses of function pointers is we use a function pointer in order to be able to pass a function as an argument or as a parameter to another function. And we do this in order to optimize our code, so in order to make our code reusable. So what I want to do now is I will delete all of this code, and then I'm going to type a code that I want to show you in order to demonstrate something amazing that we can do with function pointers. So after I type that code, I will be back. So here I have created a couple of functions, and let's now explain what every single one of these is doing. So the first one is ascending compare, and it is very simple function that just compares two numbers so that the first one is smaller than the second one. And then it returns if that is true or not. And then descending compare, again, very simple function. And again, it compares two numbers, but in this situation, the first number needs to be greater than the second number. Okay, these two are very simple. Let's see what is happening inside this sort ascending function. So if I open that function, you will notice that this here is a sorting algorithm. Now, the goal of this video is not for you to understand how this sorting algorithm works. We are going to explain that in a whole another video of C++ sorting algorithms, which I'm going to make in the future. But for now, the goal is that you understand that the job of this function here is to sort a vector of numbers in an ascending order. And one very important thing is that since we are using vector, you will need to include that vector because otherwise you are going to get an error. So that is the job of sort ascending. Now, if we take a look at sort descending, let me move this code. Okay, you will notice that sort descending function is almost identical to sort ascending function. And the only thing that is different is this part here and this part here. So our sort ascending, which is sorting numbers in an ascending order, is invoking ascending compare function, and then our sort descending is invoking descending compare function. And those are the functions that I explained in the beginning. Okay, so the next thing that I want to do is I just want to demonstrate how these two functions work. I want to test these two functions, and then I am going to show you how we can optimize this code here. So what I want to do is I want to create a vector of integers, and let's call it my numbers, like this, and I want to assign numbers of 2 and then 5, 1, 3, 6, and 4. Okay. And what I want to do now is I want to invoke sort ascending, and then I will print those numbers in order to be able to see if those numbers have been sorted in an ascending order. And for printing numbers, we will use this function here, which is very simple function that will just iterate through this numbers vector and write out every single number of that vector. So let's do what I just explained. Let's invoke sort ascending like this, and let's pass my numbers vector to that function. And after I have sorted those numbers in an ascending order, let's say print numbers, and I will pass my numbers vector like this. So if I run my program, let's see what is going to happen. As you can see, this vector here has been sorted in an ascending order. So 1, 2, 3, 4, 5, 6. Okay, so that means that our sort ascending function works as it should. And let's now test this sort descending. So here I'm going to invoke sort descending function. Everything else stays the same. So let's run our program again. Okay, so 6, 5, 4, 3, 2, 1, which means that our sort descending works as it should as well. Okay, perfect. Again, all of this code will be in the description for those of you who want to analyze how this sort descending and then sort ascending functions work. But for now, it's enough for you to understand that this one is sorting numbers in an ascending order and then this one in descending order, and that the only difference between these two functions is in this part here. So this one is invoking ascending compare, and then this one is invoking descending compare. So the next thing that I want to show you is how we can optimize this code here so that we can create one function that will be called custom sort, and we can use that function in order to sort numbers in both ascending and descending order. And the general idea is for that function to receive numbers vector, and then we are going to pass another function to our custom sort, and that function can be either this one or this one, because that is the only difference between these two functions. So let me show you how we can do that. The first thing that I want to do is I want to change the name of this function here. So instead of calling it sort ascending, let's call it custom sort, like this. And that custom sort function, as I already said, will receive numbers vector, and then it will receive a function pointer. So it will receive a function pointer to one of these two functions. So let's add that function pointer here as a parameter. One more time, how can we create a function pointer? Well, inside these parentheses, you are going to put asterisk symbol, and then you will give the name to your function pointer. Let's call it compare func ptr. So compare function pointer. Let's just call it func instead of fun. Okay, so that is the first part. The second part is to put the return type of your function in front. So here I will say bool, because that is the return type of both this function and this function here. And then the last step is to put parameters that the function receives inside parentheses after the name of your function pointer. So here. And the parameters that these two functions receive are int and int, so two integers. So here I'm going to put int and then int. Okay, so with this we have created a function pointer called comparefuncptr, which can point to either this function here or this function here. So it can point to any function that returns bool and receives two integers. So what we can do with our compare function pointer is we can use it to pass either this function or this function to our custom sort. So since this part here was the only difference between sort ascending and sort descending, if I change this with my compare function pointer, that means that whichever one of these two is passed as argument to our custom sort, that one is going to be invoked here. So that means that now we can use custom sort in order to do both ascending and descending sort of this vector here. So that means as well that now we can delete sort descending. So let's test this function here. So I am going to delete this part here, and what I want to do first is I want to create this function pointer in my main function. So I will do it here. Again, inside parentheses, you put asterisk symbol, and then you give the name to your function pointer. Let's call it funcptr, and then you put the return type of that function here. Since we want to point to one of these two functions, the return type is bool, and then they receive two integers. So the return type goes here, bool, and then the parameters go here inside parentheses, and those are two integers, like this. So we have created a function pointer that can point to any function that returns bool and receives two integers. So the first one that I want to assign here will be ascending compare, like this. So now I'm going to invoke my custom sort function here, and I am going to pass two parameters to that function. The first parameter is numbers vector, so my numbers. Okay, and then the second parameter is a function pointer to a function that returns bool and receives two integers, and that will be this function pointer here. Okay, perfect. So now if I run my program, what do you expect to happen? Write me in the comment section. So let's run the program. Okay, and as you can see, the numbers of my vector have been sorted in the ascending order. So 1, 2, 3, 4, 5, 6. And for that we have used custom sort function, and we have passed our vector and a function pointer. So we have passed ascending compare to our custom sort. So we have basically used a function pointer in order to pass one function as an argument to another function. And let's now test this with descending compare. So I'm going to say descending compare here, and that is the only thing that you need to change. And now this descending compare will be passed as an argument to our custom sort. So if I run my program now, let's see what is going to happen. Perfect. Now our numbers have been sorted in the descending order. So 6, 5, 4, 3, 2, 1. And we have achieved that by using a function pointer. Okay, So I hope that this video was helpful. I hope that you understood what is the purpose of function pointers and how you can create and use function pointers. All of this code will be in the description. Again, you don't really have to bother with understanding what these functions are doing, except for the part of how you can use a function pointer in order to pass one function as an argument to another function. So I hope that you enjoyed this video. If you did, please give it a thumbs up for the YouTube algorithm. That helps me a lot to reach more people. And then share it with someone else who would also like to learn programming, because the topic of function pointers is not very beginner friendly. So if you found this video helpful, you might make a very big difference in someone else's life, and you might help that person to learn programming much faster. So thank you very much for watching, and I am going to see you in some other video. Bye! Hi everyone, and welcome to my channel. In this video, I will teach you about smart pointers in C++. And the first thing that I want to explain is, what are smart pointers? A smart pointer is a container or a wrapper for a raw pointer. And one advantage that smart pointers have is that they deallocate memory automatically, which means that you don't have to worry about potential memory leaks in your program. There are three different types of smart pointers in C++: unique pointer, shared pointer, and weak pointer. And in this video, I'm going to teach you about every single one. So in order to use any one of these three, the first thing that you need to do is you need to include memory. So I will say include memory, like this. And the first type of smart pointers that I want to talk about are unique pointers. So the syntax of creating a unique pointer is a little bit different if you are used to raw pointers. So I'm going to show you now how you can create a unique pointer. So you say unique ptr, and then you specify the type. So what kind of data type is going to be stored on the address that you want to point to. So let's say, for example, integer. So please make a unique pointer to integer, and let's call that pointer unptr1, so unique pointer 1. Okay. And then there are few different ways to create a unique pointer, and the one that I use most often is make unique method. So I'm going to say make unique. So please make a unique pointer of integer type, and to that address I want to store a value of 25, for example. Okay, so with this, I have successfully created a unique pointer to an integer, and I have assigned the value of 25 to that address that my unique pointer 1 is pointing to. So now the question is, how do you use this pointer? And as you already know, pointers store address, and in order to access the value that is stored on that address, you need to dereference that pointer. So how do you dereference a smart pointer? The answer is by using asterisk symbol, or that little star symbol. Let me show you. So if I say cout and then unptr1, like this, so if I write out this unique pointer 1, let's see what is going to happen. Okay, as you can see, we have an address because pointers store addresses. Now, in order to access the value that is stored on this address, you need to dereference that pointer. So let's do that. And in order to dereference this pointer, you put asterisk symbol before it. Okay, so if I run my program now, as you can see, here we have the address that our pointer is pointing to, and then this is the value stored on that address. There is one very important thing related to unique pointers, and that is that they cannot be shared. So in order to demonstrate what I'm talking about, let's delete this code here, and let's create another unique pointer. Let's say unique ptr of int, like this, and let's call it unique ptr2, like this. Okay, so what is going to happen if I try to assign to this unique pointer 2 the same location that my unique pointer 1 is storing? So if I do that, as you can see, we get an error, and that means that you cannot share unique pointers. Okay, now one thing that you can do is you can move the ownership of a unique pointer. So what you can do is you can say that your unique pointer 2 is equal to, please move the ownership of my unique PTR1, like this. And now our unique pointer 2 becomes the owner of this memory address here. So if I try to write out the value that is stored on this address here, let's see what we are going to get. Okay, so I am writing out the referenced unique pointer 2. Let's run our program. Okay, as you can see, we get the value of 25. Okay, now one very important thing is that once you move the ownership of a pointer, the previous owner, which is this one, becomes null pointer. And that means if you try to access the value of your pointer that was previous owner, you are going to get null pointer exception. So let's demonstrate that. Let's say, please write out the referenced value of my unique pointer 1. And let's see what is going to happen. And as you can see, we get an exception because now our unique pointer 1 is empty. It is null pointer. And if you are not familiar with exceptions, if you don't know how to work with exceptions, you can watch the video that I will link here, and I will also link it in the description. It's called Exception Handling. And there I explain everything that you need to know in order to work with exceptions in C++. Another important thing that I mentioned about smart pointers is that the memory is deallocated automatically, which means that you don't have to worry about deallocating the memory or causing memory leaks. And what I want to do now is I want to demonstrate that. So basically, I want to create a class, and inside that class, I want to create a constructor and destructor. If you don't know, a constructor is a special type of method that is invoked when an object is constructed or created. And then a destructor is also a special type of method that is invoked when an object is being destroyed. So if you are not familiar with the concept of objects, classes, constructors, destructors, and so on, I am going to link a playlist here, which is C++ object-oriented programming, and I will also put it in the description. So C++ OOP or C++ object-oriented programming, you can watch that playlist in order to understand in more detail what I'm talking about. So as I said, what I want to do now is I want to create a class. Let's call that class my class. Okay, and inside this class, I will create a constructor and destructor. So let's first create a public constructor. So I will say public and then my class. Okay, this is a constructor, and inside constructor, the only thing that I want to do is I just want to say constructor invoked. So I will say cout and let's say constructor invoked, like this. Okay, and I also want to create a destructor. So I will copy my constructor. I will put squiggly before it. I believe this is called squiggly or tilde sign. And I will write out here that destructor is invoked. Okay, I hope that I didn't make any typo here. Okay, so I have created a class called my class, and inside it I have a constructor which, as I already said, will be invoked when an object is created. And then I also have a destructor which will be invoked at the end of the life of that object, which means when that object is being destroyed. So what I want to do now is let's delete everything from our main function because we don't need it. And what I want to do is I want to create a pointer to an object of this class here. So let's create a unique pointer like this of my class. And let's again call it unique PTR1. And I will make unique pointer of my class like this. Okay, So let's see what is going to happen if I run my program now. As you know already, constructor is invoked when an object of this type is created, and then destructor will be invoked when that object is being destroyed. So if I run this program, let's see what is going to happen. Okay, as you can see, we only have this constructor invoked. So when is this pointer here being destroyed? The answer is that this unique pointer will be destroyed at the end of the scope. And the scope of this pointer here begins at this curly bracket and then it ends at this curly bracket here. So at this curly bracket here, this unique pointer will be destroyed. And since this is the end of our program, we don't see that destructor is invoked. So what I can do to demonstrate that is I can create an additional scope. So let's do that. Let's create an additional scope like this. Okay, so now this is another scope. And if I run my program now, let's see what is going to happen. As you can see now, we have constructor invoked and then destructor invoked, which means that here at this 18th line of code, our constructor was invoked for my class object, and then at this 19th line of code, so at the end of its scope, destructor has been invoked, which means that our unique pointer has been deallocated, so we don't have memory leak. So one more time, this unique pointer will be destroyed, it will be deallocated at the end of its scope, which is here. Okay, so that is related to unique pointers, and now I want to explain what are shared pointers. So, as the name itself says, a shared pointer can be shared. Unlike unique pointer, a shared pointer can be shared between multiple owners, and that means that you can assign one raw pointer to multiple owners. So let's demonstrate how that works. So let's delete everything from our main function because I don't need it anymore. And the first thing that I want to show you is how to create a shared pointer. So let's say shared PTR. That is the keyword, and then you specify the type. So the type will be my class, so the class that we created here. And then let's give the name to our shared pointer. Let's call it shptr1, so shared pointer 1. And now I want to use a method called make shared in order to make a shared pointer. So I will say make shared of my class, like this. Okay, so with this we have created a shared pointer. Now, one very interesting thing related to shared pointers is that since you can share a shared pointer, it has the count of all of the owners. So it has the count of all of the references to that pointer. So how can you access that count? Well, there is a method called useCount. So what I want to do now is I will show you that. So I want to write out the number of owners of this pointer here. So I am going to say cout and then let's say shared count like this, and let's say shptr1, and then I will use a method called useCount like this, and this useCount method, as I already said, will give me the number of owners of this location here. So if I run my program, let's see what is going to happen. Okay, as you can see, constructor has been invoked, and then the number of owners of this memory location is 1 because we have only one pointer pointing to that memory location. Okay, let's close this. And what I want to do now is I want to share this pointer. So I want to create an additional owner to that same memory location. So let's create another shared pointer of my class, and let's call it shptr2. Okay, and what I want to do now is I want to assign to this shared pointer 2 the same memory location that this shared pointer 1 is holding, like this. And I also want to write out the number of owners of that memory location after I have shared that pointer. So if I run my program now, as you can see, in this first line, it says that the number of owners is 1. And then in this second line, the number of owners or shared count is 2. Okay. One question that you might have now is, when will this memory location automatically be deallocated? And the answer to that question is, the memory location will automatically be deallocated when there are no more pointers pointing to that memory location. Now, since that memory location has multiple owners, every single owner will be destroyed at the end of its scope, and when there are no more owners, the memory location itself will be deallocated, which means that that memory will be free for other programs and other applications to use. So let's demonstrate that as well. What I want to do now is I want to put this here into an additional scope. So let's do that. Let's create an additional scope like this. And what I want to do now is, after this scope, I want to write out the count of the owners of this memory location. So let's run our program and let's see what is going to happen. Let me know what you expect to happen in the comment section before I run the program. Okay, so as you can see, this first line says that there is one owner of this memory location, and then we entered inside this scope here, and it says that there are two owners. And then after we have left this scope, this third line, this third print says that there is again only one owner of this memory location, which means that this shared pointer, so this owner has been destroyed at the end of its scope, which is this line here. Now, another thing that I said is that the memory location itself is going to be deallocated when there are no more pointers pointing to that location. So in order to demonstrate that, let's put all of this code inside a scope. So I will put the beginning of that scope here, and then the scope will end here. And what I expect to happen is that this memory location is going to be destroyed at the end of the scope of its last owner. So if I run my program, as you can see, okay, let's move this. As you can see, our constructor has been invoked, and that happened in this line of code here, so the line where we made our pointer. And then the first output says that there is only one owner, and that is this 19th line, which says shared count, and then we have written out the count. And then when we entered inside this scope, we created an additional owner, so this second output here says that there are now two owners. And then when we left that scope and we printed the output for the third time, we get this line here, which says that again we have only one owner of that memory location. And then when we left this scope here, which is the scope of that last owner, we are going to destroy that memory location, which means that we are going to deallocate that memory so that other programs and other applications can use it. So that was related to shared pointers in C++, and now I'm going to teach you about weak pointers. So the main difference between a weak pointer and a shared pointer is the following. As you already saw, when you assign a specific memory location to a shared pointer, that is going to increase the number of owners of that memory location. But if you assign that same memory location to a weak pointer, that will not increase the number of its owners. And that means that we use weak pointers in order to observe objects in memory, but a weak pointer will not keep that object alive. So we use weak pointers in order to locate a specific object in memory, but a weak pointer will not keep that object alive if nothing else needs it, whereas a shared pointer will keep that object alive. So let's demonstrate what I just explained. So let's delete all of this code. I don't need it anymore. By the way, deleting code is my favorite part of coding. So the first thing that I want to do is let's create a weak pointer. Let's say weak ptr of, let's say for example, int. So let's create a weak pointer to integer and let's call it wePTR1. wePTR, okay. So another thing that I want to do is I want to create an additional scope like this. And inside this scope, I will create a shared pointer. So let's say shared ptr of int, and let's call it shptr1, so shared pointer 1. And let's make one shared pointer. So I'm going to use method make shared. So please make shared pointer of int, and let's assign the value of 25 again. Okay, so after I have created a shared pointer, what I want to do is I want to assign this same memory location to my weak pointer. So let's do that. Let's say that weak pointer 1 is equal to shared pointer 1, like this. Okay, so let's see what is going to happen if I run this program. I'm going to put a breakpoint here, so at the first line of my main function. And if I run this program, let's see what is going to happen. So now we are debugging this program. Okay, so in this first line, we are going to create a weak pointer, and it is still not pointing to anything. As you can see, it is empty. We just created it. We didn't assign any location to that pointer. Okay, and then after we have created that weak pointer, we are going to enter into this scope here. And inside this scope, the first thing that happens is we create a shared pointer, and then we assign the number 25 to that memory location that our shared pointer is holding. So let's do that. Okay, and if I hover over my shared pointer, as you can see, it is pointing to a memory location that has one strong reference, and on that memory location we are storing the value of 25. Okay, now in this second line of code, we will assign this shared pointer to our weak pointer. So if I execute that line of code, let's hover over our weak pointer, and as you can see, now our weak pointer as well is also pointing to the same memory location, and that memory location stores the value of 25, and it has one strong reference. But one thing that will happen when I leave this scope here is following. Please write me in the comment section, what do you expect to happen after I leave this scope here? So if I press F10 and leave this scope, and if I hover over my weak pointer here or here, there are two things that you can notice. The first thing is that it says that there is only one weak reference to this memory location, so there are no more strong references. And then another thing is that it has expired. So all of the owners, all of these strong references to this memory location have been destroyed. And now we have just a reference, we just have the address of a memory location that has been deallocated. And that is exactly what I've been talking about, which is that a weak pointer will not keep an object alive, whereas a shared pointer will. So this memory location has expired. It was deallocated when its last strong reference, so when its last shared pointer or when its last owner left its scope. And that happened on this line of code here. So I hope that this video was helpful. If it was, please give it a thumbs up for the YouTube algorithm, and also share it with someone who would like to learn programming, because many people would like to learn programming but they just don't know where to start, so you can be the one who helps them and makes the difference. And also, if you have any questions, you can leave those in the comment section, and please let me know what kind of videos you would like to see in the future. So thank you very much for watching, and I am going to see you in some other video. Bye!